Good afternoon or good evening. I'm going to stop saying good morning because I have a feeling that a majority of you watch this in the afternoon. If you are watching it in the morning when I do post it at 8, shout out to you. Good morning. If you are watching this at 1 or 2 p.m., good afternoon. If you're watching this at 10 p.m., why are you starting at 10 p.m.? That's a problem in of itself. Please make sure you're starting earlier. Okay, with that, we're going to get started because I realized Tuesday's notes was a little bit long, so we're going to keep going on this one. All right, how to set up your paper. A little bit modification on this one compared to Tuesday's. You do have one review problem that we're going to put at the top. You have 4 basic equations, so we'll do those together. This time, again, we're dealing with variables on both sides, so I really would like, actually, everybody did a great job of making sure that all of their work was shown, so please make sure all your work's shown. The only difference is I suggest putting this on the back, is we only have 2 complex ones, because otherwise if I did 4, we would be here for like 30 minutes or probably longer. So get your paper like this, we'll start. Okay, first one we're going to do is a review problem. I'm going to try to use my pen until it starts going flaky on me, and then we'll switch over to markers. We did this in some of the small groups yesterday, so if you did it in the small groups yesterday, great. Make sure that you still get it down. When I read this, there's a few things that I want to ask. First thing is, when I read it, I say find x if the perimeter is 30. I know my goal is to find x. What does x equal? I also know one other thing from this. I know that the perimeter is 30. When we see the word is, remember how like of means multiplication or like a portion means dividing? Is typically is the word we use for equal sign. So we're going to say 30 equals. And this is where I give up on the pen. It's not working. Okay. Let's start with the actual markers. So we have 30 equals. Now, I got to ask myself, what does perimeter mean? A few people yesterday said perimeter means these add up to 180. That's not perimeter. That's actually angle sum theorem. If you know that all the angles in a triangle add up to 180, perfect, but it's not perimeter. Perimeter, in your own words, means if you said that all the side lengths add up to 180, add up. I don't know why I said add up to 180. Add up. Then that's what we're going to do. So we're going to make our equation x plus 3 plus 2x minus 1. Okay, now I'm actually going to solve this equation. It's kind of separate from the problem. My first question I'm going to do is say, are there any like terms in this equation? Your answer would be yes. You got x, you have 2x. So we can go ahead and put 30 equals 4x. And now this is where I got this wrong, so shout out to Marcus and Nathan for catching me on this one. You do have positive 3 and negative 1. I covered up the negative and thought it was positive, so I added it and got 4. That's in the incorrect answer. So we do 3 minus 1, you end up getting 2, positive 2. And now we're down to a 2-step equation like we've been doing for the last few days. So the first step, again, is to go and subtract 2 from both sides. Keep it clean. It looks nice. Everything's in order. We want to be able to visualize exactly what you're doing. And then we're going to get x by itself, which means dividing on both sides by 4. And you get 7 equals x. If you did not get all those steps down, please do that right away. Get those down. Your notes should be pretty clear. I will spare you me erasing the board because I know it included last time. So here's a new board. Boom, right there. So let's start with our basic problems. Let's start with this one. When you have variables on both sides, I'm going to say this multiple times, you can either start with the variables or you can start with the constants. Constants are when you have the number by itself. The variable can go on either side. It can go to the left or it can go to the right. Either one. So what I typically do is I say, I like to put it on the left. And that's what I like to do. It does not have to be that way every time. I can move this x over here, or I can move the 7x over there. But our goal is to get all the x's, or the variables, on one side and all the constants on the other. So let me start with the constants. I got 7 and 13. I want my constants for me right now to move over to the right. That means I need to get this 7 over to the other side. Now, if there's an equal sign in the middle, if I'm crossing that barrier, that means I have to use inverse operations. So I'm going to go and subtract 7 from this constant and subtract 7 from this constant. Okay, I'm moving my constants all over to the right. So now I have 13 over here, and I've got 7 over here. So these cross out. I'm left with 6x equals, what is it, 6 plus 7x. Okay, I see this equation. 6x equals 6 plus 7x. All my constants are over on the right. If the constants are on the right, I want the variables on the left, and vice versa. If the constants are on the left, I want the variables on the right. So now my question is, how do I get this 7x to the other side? If it's a positive 7x, I'm going to go ahead and subtract 7x. 6 minus 7, careful with the negatives, you get negative 1x equals 6. Now, I can't have a negative x, so I am going to have to get rid of that negative 1 by doing the inverse operation of dividing by negative 1. And you have x equals negative 6. Ooh, variables on both sides. It's different. So, again, you can have the x's on either side. Just pick one side to put them on, and the constants on the other. So let's do our next one together. You got 7x minus 3 equals 3 plus 6x. I like to work with my constants first. I prefer to move them to the right. So what I'm going to do is take this negative 3 and move it to the right to be with that other 3. Now the opposite or the inverse of negative 3, we have positive 3. Whatever I do to the left side of the equal side, I do it to the right side of the equal sign. I also line them up so that they're specifically under the constant on the right side. So I know that negative 3 minus 3 plus 3, they cancel out to 0. I'm left with 7x on this side. Got to do my addition. 3 plus 3, you get 6. Drop down the 6x plus 6x. Okay, quick check. All of my constants, or the number by itself, are on the right. If they are on the right, I've got to move my variables to the left. So now I'm going to move this 6x, which is a positive 6x, so the inverse or the opposite would be minus 6x. And if I do it to the right, I got to do it to the left. These cancel out. We get 6 drop down. 7x minus 6x equals 1x. Now, unlike this problem where it said negative 1x, I don't have to do anything. I could theoretically just erase that 1 because it's not negative. So our answer would be x equals 6. Okay, let's look at this one. Again, I prefer to move my constants over to this side. So this time they're in a different order, but that's fine. I'm going to move this 5, which is a positive 5, over to this side. So I need to go ahead and subtract 5 from both sides. 5 minus 5, you get 2x equals 3x plus 1. Okay, so now all we need to do is go ahead and move the x's to the other side. So if I need to move this 3x to over here, I'm going to go ahead and subtract the 3x. Ooh, we're going to get to a negative again. That's fine. Negative 1x equals 1. Again, how do you get rid of the negative at 1x? We're going to divide by 1x. Negative 1x, let me squat over here. Negative 1. You get x equals negative 1. Okay, x equals negative 1. So, again, our goal is to get x by itself. Our goal is also to get all the constants to one side and all the variables to the other. Okay, last one. We are cruising. All right. A lot of negatives. My goal, I like to start with moving the constants to the right. So that means this is the constant. It's also a negative 5. So I need to do the opposite of minus 5, which would be add 5. These cancel out. You got 7x equals x. What is this? Minus 6. I also know that the invisible number in front of the x is 1. Okay? So all my constants are over on the right side. I need to move the variables to the left. So I'm going to go ahead and this is a positive 1x. I'm going to do the inverse of plus 1x and get negative 1x. 7x minus 1x, we get 6x equals negative 6. Careful that that negative drops down because it is a negative 6 over there. And then to get x by itself, we go ahead and divide by 6. X equals -1. Okay, so these are our simple ones. Again, everybody had great notes on Tuesday, so just make sure that you got these. Let's get another clean board. And now we got a new clean board with the complex. And again, we're not doing these two, so we only have 2 to do. Now, when it gets to complex, there's just one question that I need to ask before we actually do the same thing that we've been doing. Is if I cover up any side of the equal sign, like this, my first question always has to be, are there any like terms I can combine? So there's nothing there. But if I cover up this side, there are like terms that I can combine. Our like terms are 7x and 3x. Now, because I'm not moving them to the other side of the equal sign, I don't use inverse operations. I just combine them. So we have positive 7x, positive 3x. We end up getting 10x. Perfect. And then I copy everything else down. Okay, this looks exactly like our basic ones. So I'm going to still do the same thing. Move all of our constants to one side and our variables to the other. So I'm going to go ahead and move this positive 2 to be over with the -8. So opposite of +2, we get -2. Do it on both sides. We get 10x equals 8x minus 10. Careful of these negatives. -8 minus 2 equals -10. Okay, constants are on the right. I got to move my variables to the left. So I'm going to take this 8x. And the opposite of plus 8x is going to be minus 8x. You get 2x equals -10. Now the only question I have to do is how do you get the x by itself? Right now it's multiplication. So the inverse of multiplication is division. We're going to divide both sides by 2. X equals -5. I'd like to challenge you. If you think you can get this, go ahead and do this next one on your own. I am going to walk through it, so you still will have it, but make sure that you get the work done. Okay, first thing I do, are there any terms that you can combine on the side? No. Is there anything I need to do with this side? Yes. I need to get rid of those parentheses, and we've done a lot of this in the last 3 days. So I know I need to get rid of those parentheses by doing the distributive property, which means I'm going to be multiplying them. So we're going to drop down our left side, so we get 4x minus 40 equals, this is where we multiply. You got 7 times -2, -14x. 7 times +2, 14. All right, now we're at our multi-step equation. So I like to move the constants to the right. So I'm going to go ahead and add the 40 to this side. And then I'm going to line it up with the 14 over on this side. Add 40. You get 4x equals -14x plus 54. Ooh, I'm going to need a calculator for this one. Okay, all my constants are on the right. I need to move my variables to the left, which means I need to take this -14 and move it over to the left. The opposite of -14 is +14. We get 18x equals 54. This is where I need a calculator to do the division. 54 divided by 18. Okay, 54 divided by 18, we get x equals, I forget what I just saw, 3. Okay, we're officially at 14 minutes, so my apologies for this taking as long as, Tuesdays. With that being said, please make sure your notes are turned in on Flipgrid, and I will see you on Monday.